Welcome back. So, if you remember the last week's discussion, we are trying to continue it, and if you see, we are basically discussing a retro, which was again you can see in the slide, and we said the compound which will be trying to do a retro having a alpha beta gamma delta unsaturated carbonyl compound is basically aldehyde functionality. We said couple of important name reactions. Okay, we said Johnson Orchester Claisen rearrangement, we said Lucci reduction. So, what are those? So, eventually let us first start with the starting material. The starting material which was given to you is basically 3 methyl cyclohexenone. Now, the 3 methyl cyclohexenone, if you want to do a reduction, you want to do a conversion something like this, which is basically required for your next synthetic step for Johnson Orchester rearrangement. Okay. Now, for this carbonyl reduction, if you use strong hydride reducing agent like lithium aluminum hydride, you have a difficult scenario. You might have a 1,2 reduction as well as 1,4 reduction. So, both the product you will be getting, and you do not want to do this. Even sometimes sodium borohydride, which is supposed to be a milder reagent, that also does the same thing. So, in this case we are using a particular reagent condition which is named as cerium chloride and sodium borohydride. It is called the Lucci reduction condition, and this Lucci reduction condition will give you extensively 1,2 reduction in alpha beta unsaturated compounds. It is a very mild and chemoselective reduction. So, once this Lucci reduction was done, you can next follow that we need to do a Johnson-Claisen rearrangement, Johnson-Claisen rearrangement, which was given us. Now, what is Johnson-Claisen rearrangement? We will now next try to focus on Johnson-Claisen rearrangement. It is a very important transformation. Johnson-Claisen rearrangement is basically a 3,3 sigmatopic rearrangement. Okay. Now, what you need? You basically need a allylic alcohol as a starting material, and you need to take this triethyl ortho acetate. Sorry, this will be OET, OET, OET. So, MEC, OET, OET, OET. So, initially you mix those two compounds in presence of a acid catalyst. You need acid. Actually, you will be getting a intermediate whose structure is this, and this structure you can basically figure it out how it has been generated. The very initially there will be a trans esterification kind of reaction. So, where one of the ethyl group will be replaced by this allyl group. Okay. So, you can pick it up this ethanol as a byproduct and put this O allyl here. Okay. The next step, you are subjecting this compound with high amount of heat and H plus, then one of the ethyl OET, and from this methyl one hydrogen will undergo 1,2 elimination to another round of ethanol elimination. So, 2 equivalent of ethanol will be eliminated by this reaction, and you will be getting this part is coming from this allyl part, double bond CH2O, CH2O. Okay. Then one of the OET remains here, and this things coming from this methyl. Okay. Now, it is very nice and interesting reaction, this probably all of you know. Subjected to heat, a 3,3 sigmatropic rearrangement takes place. This all of us probably know, and then what you will get? You basically get a compound like this, which is alpha, beta, gamma, delta. So, the general retro for this kind of compound, whenever you are having a alpha, beta, gamma, delta unsaturated compound, these things you can straightforward do a retro based on Johnson Orchester rearrangement, Johnson Orchester Claisen rearrangement. That is the basic transformation which you are looking for, basic transformation. But this information you need to have it So, it is a alpha, alpha means alpha to carbonyl, then alpha beta is a gamma delta. So, basically it is a gamma delta unsaturated carbonyl compounds, and eventually this is a very important transformations. We will be trying to figure it out, this transformation throughout our courses, and you will find that is a very important, very interesting reaction. Fine. So, coming to another quiz is again based on a very simple transformations, and let us see how it was designed. The starting material was a simple starting material, it is basically having a cyclopentene framework. You see cyclopentene framework, you are having a methyl here, you are having a CO2 Me here. So, it gives a all substituted carbon substituted things. At the one left hand you are having a alpha beta unsaturated aldehyde. So, this is pretty small molecule. The retro was very much simplified retro. First retro was a intramolecular aldol type of reaction. So, how you basically cut this bond, as I say this is your retrosynthetic bond disconnection, and what you will do, you basically remaining part you keep similar, and let us see. So, this is your initial retro, which will be something like this. So, you have a dialdehyde, and this dialdehyde we assume that one of this aldehyde will abstract the alpha hydrogen and will attack to the another aldehyde. Now, there must be regiochemical issue definitely, but probably I said that this aldehyde having in between 2 CH2 group or 2 methylene group, or this aldehyde is having 1 methylene group. So, these groups are basically very close to this aldehyde, but this aldehyde having little bit far away from this group. So, this group does not exhibit or does not exert a steric crowding here. So, hydrogen from this aldehyde alpha hydrogen can easily be abstracted compared to this aldehyde. That was the initial thought. So, fine. Now, you do a intramolecular aldol reaction, which is very straightforward transformation. Now, the starting material, how can you make the starting material? The starting material, as it is a dialdehyde, you can straightforward go to some compounds like this. Now, what is this reaction? It is basically oxidative cleavage, or you can say ozonolysis. So, it is a oxidative cleavage, Now, this kind of reactions are basically very much fundamentally useful, and you will find in many cases if you have a cyclic compounds, you want to cleave these kind of compounds to corresponding dialdehyde, and what are the reagent of choice? What kind of reagents you want to use it? The best reagent is ozone, you can do a ozonolysis. There are other reagents. The transformations, first you do a dihydroxylation, then you do a sodium periodate, which is named as Johnson-Lamux reaction. The spelling you have to check it, Johnson-Lamux reaction. C, you can do a MCPBA mediated epoxidation followed by water treatment, that will give the diol, then you do the same thing Johnson-Lamux. The other reactions, you can first make the diol by making this reagent, and then you treat with lead tetraacetate, which is also cleave the corresponding diol to aldehyde. So, these 4 conditions basically you can use for diol cleavage, and that serves a very nice interesting pathway, or it is called oxidative cleavage to give you. Okay. So, now you are here. Okay. Now, what will be the next retro, further retro? We have already shown in the slide. The next retro is basically simplifying it by a 4+2 delete cellular cycloaddition or delete cellular transformation. So, this is your diene and this is your dienophile methyl methacrylate, and basically if you can do a 4 pi plus 2 pi cycloaddition reaction, you can get the corresponding product, which is one of the intermediate. Do a oxidative cleavage by ozonolysis or any of these 4 method which has just discussed. Then you can do a intramolecular aldol reaction. This is the transformation which is intramolecular aldol reaction. So, this was the main key reaction or key synthetic transformation which we will be using to access this molecule, and probably if it is not very difficult, you have to see the molecule first and then you can eventually try to design the pathway which will be suitable for you. The next one is absolutely tricky. I said you have to make this kind of bicyclic compound. Okay, sorry, this structure is wrong. So, I said you have to make a bicyclic compound which was drawn in the slide without using the Robinson annulation. Now, remember last week we talked about Robinson annulation, which is basically a combination of Michael and aldol reaction. We talked about Robinson annulation. Okay. Robinson annulation means the ring formation reaction, and we said Robinson annulation is nothing, is a combination of Michael and aldol reaction. Okay. Now, here we have given a prerequisite. The prerequisite is you cannot use Robinson annulation. I said without using Robinson annulation. The starting material which was given to you, similar kind of starting material which was used in the Robinson annulation. That is absolutely tricky. So, you have to devise a other pathway which is not exactly similar as Robinson annulation pathway demands. Okay. Now, let us try to analyze this pathway. The initial retro was basically shown into the PowerPoint. So, I say if you have this target molecule, you devise a pathway which looks this. Now, how you can, this is basically the final pathway in Robinson annulation. What do you say? Okay. Robinson annulation we do Michael and aldol. Okay. That is the combination. We said if you have this kind of carbonyl compounds, you can basically do a aldol reaction. That is fine. That is the final pathway in the Robinson annulation. The next one you see is a absolutely tricky pathway. We devise if you have a intermediate something like this, and we do a retroaldol kind of transformation. Now, what is the retroaldol reaction? It is the reverse of a aldol reaction. It is the reverse of a aldol reaction. Similar like a retrosynthesis is the reverse of a synthetic steps, is the reverse of aldol reaction. Okay, reverse of aldol reaction. Now, see how this retroaldol takes place. This is a 5-member ring, this is a 4-member ring, and we generally know that 4-member rings are strained. So, what happens if you subject this molecule to a base, it will try to open it up and will give a negative charge here, because it is linked to a COMe group which is electron withdrawing, which can stabilizing. So, then if you have a retroaldol kind of transformation, that will basically give you C double bond O here CH2 CH2, this is the CH2 where is going to be originated after the cleavage. So, in principle the cleavage is like this. This is a 4-member ring 1, 2, 3, 4. Okay. So, this is the cleavage. Now, later on we will be seeing that this kind of strain intermediate or strain ring containing compounds are named as overbred intermediate. we will be discussing it in detail in the subsequent section. We said the intermediate which are strained are named as overweight intermediate, and they have a very significant application in the field of organic synthesis as well as retrosynthesis. Fine. So, now whenever you have a choice to make a 4-member ring, my suggestion is straightforward, go to a 2+2 photochemical reaction. That is probably the one of the best reaction available in the literature or available to the synthetic organic chemistry community. So, now you can easily find it out what is the 2+2 retro. So, 2+2 basically you will be requiring this vinylic alcohol and you require a methyl vinyl ketone. Fine. Where from you get this compound? This is nothing, this is the enol form of the corresponding ketone. Now, you see the starting material which was required in the Robinson pathway is also similar. So, if I have to do a Robinson pathway, which I says you cannot use it in this case, the pathway for Robinson also similar, I mean the starting material is exactly similar. Methyl vinyl ketone. So, initial Robinson pathway is basically this is undergoing a Michael thing and then you have a aldol if you rotate this molecule. But here the starting material is similar, but instead of initial Michael reaction, initial Michael we did not do, initial Michael we replaced it with a 2+2 photocyclo addition, provided that the ketone is enolizable. So, make sure the ketone is enolizable. So, you can make the ketoenol tautomerism enolization and then this starting material, this vinylic alcohol react in 2+2 fashion. Okay. Now, eventually this reaction is now named as, or it is known as DiMeo reaction. It is named as DiMeo reaction. What is DiMeo reaction? DiMeo reaction is basically a combination of 2+2 photocyclo addition, photochemical addition I say, and a retroaldol reaction. So, DiMeo reaction is basically a combination of a 2+2 H nu addition for photocyclo addition and retroaldol addition, and DiMeo reaction is very significantly useful reaction, significantly important reaction. You will find in the couple of next slides when you talk about more transformation based approaches, and you find that DiMeo reaction is absolutely brilliant to work with. So, okay, next what we will talk about these things. So, this part is basically our quiz part ends here, and finally, I will give you a list of resources available in online. Probably the best resources you can try is this one, this scenarchive.com. This scenarchive.com is a fantastic reaction, it is a fantastic website which basically gives you a, you can try to search it from your things. Now, we just have a look, the scenarchive, the scenarchive.com basically gives you a complete idea. You can get the different name reaction, you can get different name reaction, just click it, just click the different name reaction, you will get a all name reaction which are basically potentially good transformation. So, all the transformation have been, just now we said DiMeo reaction, okay. This is DiMeo reaction. So, click it, click to the DiMeo reaction and then you will find that DiMeo reaction, just now the similar kind of example we taught is a DiMeo reaction. It is a ketoenol tautomerism, then you have a 2+2 cycloaddition followed by retroaldol cleavage. So, this scenarchive will give you essentially a huge resources for you, it is free, it is web based service and you can access from your smartphone. If you have an internet connection, you can do it. And probably throughout this lecture, we will try to go through many of these transformation which you will find useful. Okay, now coming to other component of these things, there are many other things which is basically available here. let us say you are having several synthesis organic synthesis available, like synthesis by molecule. There are many natural products or target molecules have been listed here, a series of target molecules. You can basically scroll them down alphabetically, like see different molecules which have been listed here, and many of the molecules if you just click them, they opens up and you can just go through it, how the synthesis has been reported in the literature by the scientists, great scientists, as we name them, many of the scientists in the last class. We find quite interesting molecules. Probably some of the molecules we will cover in this series as a potential target molecules, and how those molecules can be synthesized. You can have a initial hand on idea, or you can just view it over this website. You can design the pathway in your independent thinking, and definitely the reactions, if some reactions are not familiar with you, you can also access the reaction throughout this portal. So, this is one good resources which is available to you. Sometimes this also helps, is called organic chemistry or organic reactions. This portal is a good things which basically give you a series of organic name reaction, and then similar kind of thing, starting from alphabetically you can basically access a series of name reaction. And let us say we talked about Barch reduction. At the Barch reduction, you can just click it out. Okay. Then you see this Barch reduction is very interesting, and whatever mechanism I have shown it here, you can get the instant access. I said if you have electron releasing group like anisole, you can basically think about the regiochemistry. If I said electron withdrawing group like benzoic acid, you basically get this kind of compound. So, this portal also is a very useful portal, and that gives you an idea that what are the name reactions are available in the literature, and what you might not know actually, and then you can just click them out and you find those the name reactions. Even this slides this particular website gives you a lots of name reactions, and then you can just go through it. Obviously, our in our subsequent discussion we will try to cover some of the name reactions, but definitely due to time constraint, due to space constraint, we may not cover everything. So, if those resources are available to you, you can easily access them, and those are absolutely free, and so these two are basically the main resources we will be talking about. There are many research journals available here, but I won't recommend these journals to you at this moment, because these are made for the specific researchers. So, you no need to access these journals currently. So, you can basically access these two websites, and these websites will give you a very good idea that what you can think about based on a synthesis. Particularly Scene Archive, all the molecules, a retrosynthetic pathway has been given, and if you click for this, let us click the Scene Archive again, and then you browse synthesis by molecule. So, means that we will now target any molecule. Let us say molecule. Okay. I will click this molecule. Now, see this molecule, they said that this molecule having this structure, there are this molecule was reported in 1984. The investigator is Leo Pacuiti, is a great organic chemist, and see the entire forward pathway was given to you. So, if you want to get experience in the forward pathway, and then you can think backward, basically first see the forward pathway, and then you can devise independently a pathway that okay, this route is known. Okay. So, by somehow can it be thought in a different way, and that will give you a independent thinking that whether a new pathway, altogether a new pathway can be designed, but definitely that must be validated experimentally. As I said, organic synthesis is a purely experimental science. So, you might have a 10 designed pathways in a piece of paper, but until and unless all the pathways are validated, those pieces of paper are basically useless. So, out of 10 might be one pathway can be validated in this lab setting. So, these are the information you can basically work it out, I mean you can work it out, and this information will be really helpful. And obviously you can contact me through this NPTEL platform regarding any clarification. So, okay, we will see you in the next week. So, till today what we have discussed, just go through it, and if you have any clarification, we can clarify your doubts in subsequent section. So, have a good time.